Alright, so we're going to be starting our next chapter. We're skipping chapter 2, we're on chapter 3. Today we're going to be talking about two different ELRs, 3.1 and 3.2 from chapter 3. We're going to be exploring properties of intersecting lines and special angles that are formed when we have two parallel lines cut by a transversal. Alright, so let's get through some key terms here to start. What are parallel lines, parallel planes, and skew lines? So these should be written in your notebook. So parallel lines are lines that are coplanar. So that means they lay on the same plane and they don't intersect. And I think everyone knows what parallel lines, but this is a fancy word, coplanar. They're on the same plane. So over here in this lovely 3D picture I tried my best to make, line AE. Here is the symbol for parallel, right here, this thing with two lines going up. That's the symbol for parallel, is parallel to BF. So these two lines are parallel. On the actual picture to show parallel, if you notice, they have arrows. So if they have an arrows here, that means they're parallel. Here we have two sets of arrows, so that means these two lines are parallel, BC and AD. Parallel planes, planes that obviously do not intersect. So I can have this plane up here, ABCD, is parallel to EFGH. And there are lots of them here because it looks like a cube. And then this might be a new term here, something called skew lines. Skew lines are non-coplanar, so they're not on the same plane, and they are not parallel, and they do not intersect. So it's basically anything else that's what I have listed up here. So looking at this picture here, AE is skew to BC. They're not on the same plane. Let's do this in green. AE, this one is skewed to BC. Not on the same plane, not parallel, and they do not intersect. Alright, moving down.
Moving downtown. Ooh.
Alright, there is a PDF that I have if you'd like to print it out. If not, you could just copy this. It's called Parallel Lines Cut by a Transversal, the Location of Angles. So in this chapter, you need to be able to locate all these specific angles that are named here. If we were in school, we would have been able to do a little activity, like with music and dancing, but we're not in school, so we'll be just locating it here. So, here I have two parallel lines. Here, that means parallel. Here's the transversal line right here that's cutting through the two parallel lines. And if you notice here, we have 8 different angles being formed, so they're labeled 1 through 8. On this picture, we need to locate different things. So the first thing we need to locate is where are supplementary angles. So supplementary angles from chapter 1 are angles that add up to 180. Angles add to 180. So we're looking for a straight line, a straight angle. So we have so many straight lines here. So if I take angle 1 and angle 2, those are supplementary angles. They lay on a straight line. What else could be supplementary? 3 and 4 down here, also a supplementary. 5 and 6 are supplementary, laying on the straight line. 7 and 8 are supplementary. I can even go the other way and do it this way. 6 and 8 are supplementary. 5 and 7 are supplementary. So on and so forth. Alright, here's something new. A new kind of angle called corresponding angles. Corresponding angles lay in the same position relative to the transversal. So let's do this in some colors here. So 2, if you notice, is on the top here of this parallel line with this transversal. So in the same position would be right down here, 6. So angle 2 and 6 are corresponding angles. What would be another pair of corresponding angles? 4, angle 4, and angle 8. They're in the same position relative to the transversal, 4 and 8. Let's talk about the other side. 1 is going to be corresponding to 5. 3 is going to be corresponding to 7. So those are corresponding angles. Alright, next one. Alternate interior angles here. So looking for interior angles that are in the parallel lines. So here are the parallel lines. So we have 3, 4, 5, and 6 are in the parallel lines, but they're alternate. Oops, I forgot the end. Alternate. So what would be alternate? They're on opposite sides of the transversal. So 4 and 5 are in the parallel lines, and they're alternate, 4 and 5. Another pair of alternate interior angles are 3 with 6. Those are alternate interior angles. Next one, alternate exterior angles. Same concept, except now they're on the outside of the parallel lines. So here are the parallel lines. Outside are 1 and 2, 7 and 8. So which are alternate? 1 and 8. And the other pair of alternate exterior is 2 and 7. Okay, last type of angle that we need to know where they are located are same side interior. So again, interior in the parallel line. So 3, 4, 5, 6. Which ones are on the same side together? Well, 4 and 6 are on the same side inside, and then 3 and 5. So real important knowing the position of the angles. All right. Now, coming up over here.
Oh.
Here we have another PDF if you do want to print it out. If not,
Cannot. Okay.
You got it?
Yeah.
The PDF is called Special Properties of Angles when two parallel lines are cut by a transversal. So there is a PDF on this if you do want to print it out. If not, you could go ahead and just write this up in your notes. So we have here line M parallel to N, and then we have our transversal here A. A lot different way of the parallel lines. It's switched now, the board, than compared to what we had over here before. So these things are going to be rotated all different ways. You just need to be able to locate it. What are the inside angles? So 2, 3, 6, and 7 are in the parallel lines. 1, 4, 5, and 8 are on the outside exterior. So the angles that we just learned of before, we're going to be using those, but they have special properties. Alright, so alternate interior angles. So let's see if you could locate them on the picture. So alternate interior angles are inside but alternate. So remember, 3 is going to be alternate interior to 6 here. And what's special about them? They are, equal, congruent. So the symbol for congruent, I don't know if you know this, we've got the equals with the little squiggle above it. So that means they have the same measurement. So 3 and 8 are, I said 3 and 8, 3 and 6, sorry, 6. My bad, 3 and 6. Those are alternate interior. What also is alternate interior? 2 is congruent to 7. Those are also equal. We located alternate exterior also from before. Those are on the outside of the parallel lines, alternate. They are also equal. So 1, 5, 4, and 8 are on the outside. Which ones are alternate? 1 is equal to 8. And 5 is congruent to 4. So these angles are equal. Alright, next one. Same side interior. So if I take the interior that are on the same side, so these are the interior angles, which ones are on the same side? 2 and 3, 6 and 7. If I knew one of them, if I add them up, they add up to 180 degrees. Same side exterior, so the exterior on the same side are also add up to 180. So 1 plus 4, because they're on the same side, on the outside, also equal 180. 5 added up to 8 equals 180. Alright, last special property for these angles are those corresponding angle ones that are same position relative to the transversal. They are always equal. So let's see if we can find the corresponding angles here when it's turned. So angle 1 here is in the same position on the transversal as 3. And it looks pretty similar if you notice. So 1 is congruent to 3. 2 on the same side of the transversal is congruent to 4. We have 5, angle 5, corresponding to angle 7. And then the last one, 1, 2, 3, 4, 1, 2, 3, 4. Those are showing that those specific angles are equal with the tick marks. Angle 6 is congruent to angle 8. Alright, now how are we going to use this with algebra? Alright, so let's take a look at this question down here. Alright, here we're finding a measure of each numbered angle. So we got L parallel to M, notice with the 2 arrows, P parallel to Q. So we have 2 sets of parallel lines. So you could pause the video and see if you could figure out the measurements of these 8 angles. I'm just going to go ahead and start my explanation. So we have 105 degrees here. What else could I get that's also 105 degrees? You never ever ever want to go across to another transversal over here. This is its own transversal working on here, this M here. So let's just take a look at 5, 3, and 7 first. That's my suggestion. So 3 and 105 degrees. Who knows what type of angles those are from what we learned above? These are alternate interior angles, and alternate interior angles are equal. So that means angle 3 is 105 degrees. What else could I get with angle 5 and 7? One thing that you should hopefully remember, and I'm going to do it actually now, is who remembers what vertical angles were? They were equal in chapter 1. What is vertical to angle 3? Angle 5. These are vertical angles, so they are equal. Another possibility that you could have thought of was that angle 5 is corresponding to the 105 degrees, right? Because they're on the same position relative to the transversal. That's another thing that you could think of. Alright, how can I get angle 7? Lots of ways. Again, 7 and 105 degrees are vertical. You could think of these being corresponding, they're equal. You could think of alternate exterior, they're equal. Alright, now how am I going to go from here all the way over to this other side? Well, now we're going to pretend we're going to turn the whole board around and take a look at these 2 parallel lines here, L and M. Here's its own transversal going this way, P, kind of like that one up here. So what can I get for 2, 8, and 1? Alright, let's take a look. This is 105 degrees, which makes 8 105 degrees because they're alternate interior. Now we have 2 and 1. What can I get from that? I don't see anything else, but we should remember about supplementary angles. 1 and 8 are supplementary. They're a linear pair. They're on a straight line together next to each other. So what's 180 minus 105? 75 degrees is left. 1 and 2 are vertical. This is also 75 degrees. Or think of, again, supplementary. Now we need to go down this way, 4 and 6. So now we're going back to this again, parallel, but now looking at L as the transversal line. So let's see. We have 8 and 4. What's the relationship? Or we could do 1 and 4. These are alternate interior. This would have been same side interior, add up to 180. And then how can I get 6 down here? Let's see. We could do 4 and 6 are supplementary again. They lay on a straight line. This is 105 degrees.